All right, let's actually get into graphing now. So there are different ways that we can graph equations, but one of the most basic ways is to use what's called the plotting points method. And I just kind of wrote some general steps here for how to do that. So what you do is you choose any value for either x or y. In general, you could pick anything you want. Normally, we pick values that are smaller to make our life easy, but you could pick anything you want, and you're going to plug it into the equation. But you just pick one value. So either pick a value for x or pick a value for y, plug that into the equation. Then you're going to solve for the other variable using all the regular solving techniques that we've learned. And then what you do is those two values go together. So whatever you have for x and y, that becomes one pair or one point. And you repeat that process over and over again until you have enough points that you can graph and actually see the pattern or the shape of the equation. Now, for your more simple equations that are lines, which we'll see more in the next section, so when you don't have any squares or cubes or anything weird going on, then 2 points is sufficient. If you have anything that's a little bit more complicated, then you want to have more points. So basically, you just keep picking points until you've graphed enough to see what the pattern is and know what the graph is going to look like. So we have an example here. We're going to graph that same example that we've been talking about. We're going to select integers for x this time. And the book wants us to start with -3 and end with 1. Now, what I'm going to do is I like to make myself a table to stay organized. So I'm using x values this time. I'm going to start with -3, and they want me to use integers. So I'm going to do -3, -2, -1, 0, and 1, which is the last value. And I'm just going to plug these in one at a time. So y equals 4 minus x squared is my starting equation. And I'm just going to pick my x value. Here, x equals -3. And I'm going to just replace my equation, my x in my equation, with my number. So I get y equals 4 minus -3 squared. Now, -3 squared is +9, so make sure you do your square first, right? This is -3 times -3, so you get +9. And we get y equals -5. Now, hopefully you're not surprised here because we saw this point already. Now you kind of know how they found it. And now I do the next one, -2. So y equals 4 minus, this time I'm plugging in -2. Now again, be careful here. We're going to do that square first. -2 times -2 is +4. So we get y equals 0. Next, I do -1. So y equals 4 minus -1 squared. And again, -1 times -1 is going to be +1. So I get y equals 3 here. We have some more room. I'm going to come over here. Let's do x equals 0 next. So y equals, 4 minus 0 squared. Now 0 squared is just 0, so 4 minus 0 is 4. And again, we've seen this point already too. And finally, my last one, x equals 1. So y equals 4 minus 1 squared. Well, 1 squared is still 1, so I get 3. Now, you can leave the table. I think the table is pretty nice and organized, but if you prefer to write it as points, each of these is a point. So this is the point -3, -5. This is the point -2, 0, -1, 3, 0, 4, and 1, 3. So you have all your points there. For me, I just like to have that nice table form. I find it easier to keep myself organized along the way. But it's still the same points. So I'm going to go ahead and plot these. So let's see, I have -1, 2, 3, and then -5. 1, 2, 4, 5. So I'm right here. Then I have -2, 0. I have -1, +3. I have 0, 4. And I have 1, 3. Oops, hang on, I plotted one of my points wrong. Oh, I made so many mistakes, guys. Hang on one second. Let me redo this. -3, 5, -2, 0, -1, 3, 0, 4. I don't know why I plotted 2 there. That's what threw me off. And then 1, 3 should be right there. Sorry about that, guys. That looks much better. So here's my graph. So again, even I make little mistakes. So I plotted one of my points wrong. I counted to 2 instead of 4 by accident, which is super silly. And then because of that, I threw myself off on the second one too. So just double check your work. I looked at my points again. I said, okay, something doesn't look right here. So I redid it. Now, one thing to note when you have squares, the reason I was able to recognize it didn't look right is because when you have a square with no higher power, so no cubes or fourths, you do get these nice parabolas or U shapes. So sometimes they're going down, sometimes they're going up, but I was able to recognize that something didn't quite look right. So I went back and double checked my points. So this is what our graph should look like. All right, let's do another example. All right, so the toll to a bridge costs $2.50, and commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $21. With the discount pass, the toll is reduced to $1 instead. The monthly cost Y of using the bridge X times can be described by the following formulas. So your cost for using the bridge without the pass is $2.50 times X, where X is the number of times that you actually cross the bridge, right? So it's $2.50 times X. If you have the pass, well, it only costs $1 for each time that you cross the bridge, but you pay $21 first for that discount pass. So your formula instead is Y equals 21 plus X. So those are our two cost formulas. Now, what they want us to do here is let X be 0, 2, 4, 10, 12, 14, and 16. We're going to make a table for each equation showing all these solutions. Then we're going to graph it and then answer the rest of the questions. So let's just get organized here. So I'm going to do my first equation with my table here. And I want to plug in 0, 2, 4, 10, 12, 14, and 16. Now, to make it a little bit easier, I'm just going to kind of do my work in the table this time. So I'm going to replace my X each time with the X value that's here. So my Y value is going to be 2.5 times 0 here, which is 0. This one will be 2.5 times 2, which is 5. Just want to make sure I'm not making silly mistakes. All right, and then I have 2.5 times 4, which is 10. 2.5 times 10, which is 25. 2.5 times 12, see, and that's going to be 30. 2.5 times 14 is going to be 35, and 2.5 times 16 is going to be 40. So I have my points here. Again, if you want to leave the table, you can, but if you want to write these out nicely, you can. So I have 0, 0, 2, 5, 4, 10, 10, 25, 12, 30, 14, 35, and 16, 40. So there's my first set of points. Now I'm going to do the same thing for my second set of points. I'll use pink this time. And I have my X. My Y here is a different formula. It's 21 plus X. But I'm still going to plug in the same values. 0, 2, 4, 10, 12, 14, and 16. So for my Y value here, I have 21 plus 0, which is just 21. Then I have 21 plus 2. So again, I'm filling in for my X each time, which is 23. Then I have 21 plus 4, which is 25. 21 plus 10, which is 31. Let's see, 21 plus 12, which is 33. 21 plus 14, which is 35. And 21 plus 16, which is 37. So my points here are 0, 21, 2, 23, 4, 25, 10, 31, 12.33, 14.35, and 16.37. So we have part A done with our table, and now we're going to go ahead and graph. So I kind of just left us a blank grid here so we can start it ourselves. And with application problems, you want to think about what's going on. So I want you to notice that in each of these cases, we have no negatives, right? It doesn't make sense to have a negative cost in this case. If you're paying to cross a bridge, you're not going to get money back. So we're going to focus on the first quadrant instead here. So I don't really want to do my entire 4 quadrants. I don't really need the quadrants that have the negatives. So instead, I'm just going to focus on that first quadrant. And I'm going to zoom out a little bit and make that X and Y chart. Now, we got to figure out our spacing here. So I want to think about my values. On my X-axis, I have to go up to at least 16. So I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks. So going by ones is not going to work. So this could be a good chance maybe to go by twos. So I'll use 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then for my y-axis, let's see, our highest value is 40. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marks again. So if I go by twos, 2 is still too small, right? I get only 24. So maybe I want to go by something higher. This could be a good one to go by 5s. If I look at a lot of my data, not this one as much here, but I have a lot of 5s at the end of my data. So I'm going to go by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, and I'll just go up to 60 here. And then over here, again, we have our total monthly cost, and this is in dollars. And then on our x-axis is the number of times we cross the bridge. So just giving some labels to our axes. We always want to get in the habit there of kind of labeling our axes, giving titles and things like that. So now let's go ahead and plot. All right, I'm going to do this first one in green. So I have 0, 0. I have 2, 5. I have 4, 10. Then I have 10, 25. Then I have 12, 30. 14, 35. And 16, 40. So this looks like a nice straight line here too. So I would probably want to get out some sort of straight edge or ruler. I'm just going to use a piece of paper and make that line. Now, technically that line is going to keep going because you could cross the bridge more than 16 times. So that's our first line. And then I'll use the pink color for the other line. I'm going to have to estimate here. So I have 0, 21. So here's 0, here's 20. So 21 is just a little bit above. Then I have 2, 23. So about halfway in between 20 and 25. Then at 4, I'm right on the 25. At 10, I'm at 31. So let's see. Here's 30, and then a little bit above would be 31. Then at 12, I'm at 33. So again, kind of halfway in between the 30 and the 35. And at 14, I'm right at 35. And then at 16, I'm at 37. So a little bit. And again, I have a nice line here as well. So I'm going to go ahead and use my straight edge to get my graph. So this is the graph of y equals 21 plus x. And then this is the graph of y equals 2.5x. All right, last question. What are the coordinates of the intersection point of the two graphs? So that means where do those two graphs cross? And we can see pretty clearly they cross right here, right? So that point happens to be the point 14, 35. And I can also see it in my table. So you may have noticed already that that same point repeated itself. So that's your intersection point of these two lines. That's where they cross. And we're going to interpret the coordinates in practical terms. So remember here that our x is the number of times we cross the bridge, and our y is the monthly cost. So what this says then basically is that when we cross the bridge 14 times, the cost is $35. Okay? And actually even more so than this, just kind of analyzing this, it costs the same at this point, whether we have the pass or we don't have the pass. So whether we have the discount pass or not, right? Because they're equal, right? They cross at that same point. If they intersect, that means they're equal at that point. So here you have that same cost. Now, the question doesn't ask you to go any further than this, but I think it's a nice example just to talk about. So notice how before this point, that red line is on top and the green line is below. So that means that the red line is costing more this entire time until we hit that intersection point, which makes sense. Look at, if you look up until 14 and you look at your costs, you're up here at 33, 31, 25, 23, and 21, which are bigger than your numbers here along the way. So we don't actually start seeing a reduced cost in that pink line. So now the pink line is lower than the green line. So now the cost is lower until after this point. So if you're buying your discount pass, you have to use it at least 14 times for it to make sense and to save you money, right? So after 14 times, we do see that the equation with the discount pass becomes lower. So your cost is going to be lower. But if you're crossing that bridge less than 14 times, then you're better off just paying per time and not buying that discount.